We're going to look at Test Bank Problem 59-60 from Chapter 7. This problem is very similar to a problem in 7.6, specifically example 7-10. And some of the things will be given is N and P. We'll have to calculate Q by taking 1 minus P. The mean of the sample proportion that is taken out of all Americans is going to be the same as what's given. So this P hat is going to be given in the problem. It's going to be the same as P. So the standard deviation of P hat is going to be calculated as P times Q over N and the square root of that. One thing you'll want to check is N and P are greater than 5. If that's the case, we can infer from the central limit theorem that the sample distribution is going to be approximately normal. Being able to do that allows us to calculate a z-value for a p hat, and that is this formula, very similar to what you've seen in the past. Once we get that z-value, we can go to a standard normal distribution curve and find the area to the left of that z-value. And then plan accordingly to what the problem's asking. If it's asking for an area in between or an area greater than, we might have to take 1 minus that value. So let's look at this example. P is given as 18.4%. And you might want to always write percents as decimals. It keeps your calculator be able to calculate it a little quicker. Q is going to be 1 minus 0.184. So that's 0.816, and then N is given in the problem as 550. Now, the mean here, mean of P hat equals 0.184. It's the same. Your book doesn't, this here is going to be this P hat value. When you're converting it to the z, that's going to be the p hat value you're wanting to find the corresponding z value to. P is really the mean of the population of p hat. So sometimes it's not as clear in the book, but I just want to kind of clarify that. You should also think a little about what's going on here. You want to find the standard deviation, that's the square root of N times Q, not N, P times Q over N, and calculate that with the given numbers. We get this number. You want to make sure you carry out your decimals as much as you can. We're looking for an approximate answer, but rounded to 4 decimals, because our standard normal distribution curve will only give us 4 decimals, but we want to wait to round anything into the very end of the problem. So we have the standard deviation and we have the mean. The next step is to find the corresponding z-value for 18. Right? So if I draw the normal standard distribution curve and I have this 0.184, 18% is on the left of that. So I want to find the z-value for p hat being 0.18. Right? I should expect this to be negative because it's less than 18.4. So if you get confused on the p hat minus p, the order, just kind of think about where in this normal distribution, is it less than the mean or is it greater than the mean? If it's less than the mean, the z-value is negative. If it's greater, the z-value is positive. So here, if I wasn't for sure necessarily on the area or on the order, I need to know that my z is going to be negative. So 0.18 minus 0.184 over the standard deviation, which was calculated above, and that will give me negative 0.244. Now here I only have 2 places to calculate. So look at the third, I'm not going to round. I'm going to go to the standard normal distribution curve, and I'm going to look at minus 2.4. And that is given right here. 0.4052. So the area for p hat being 0.18 is going to be 0.4052. That is the area to the left. But the problem wanted to know, what's the probability that more than is to the right. We know the standard normal distribution curve, the whole probability is 1, so the answer is going to be 1 minus 0.4052, which gives us 0.5948. The next one wants to know the probability is less than 22.5%. So I'm looking for the corresponding z for p hat being 0.225. In this case, I'm going to be on the right side of this 0.184, 0.225. So my z value should be positive, right? So 0.225 minus 0.184 over the standard deviation, which would give me a positive 2.503. I only have two places after the decimal, so I'm looking for the area. In this case, it wanted to know the probability is less than. So if I go to the standard normal distribution curve and I'm looking at 2.5, up here it's already calculating less than. It's calculating this area. So I'm not going to have to convert it. 2.5 is 0.9938. So the area is 0.9938. That would be the answer there. If you have any other questions, please let me know.